Hello dear students of plus 2 medical and non-medical respected teachers. Today I am going to discuss behavior of a charged particle under the influence of a uniform perpendicular magnetic field. So we will consider a charged particle having mass m, charge q, entering a uniform magnetic field shown by these crosses, which is directed inward to the board and perpendicular to the plane of the board. Then by Fleming's left hand rule, your first finger gives the direction of magnetic field, central finger gives the direction of motion, then thumb will give you the direction of magnetic force. It means magnetic force will act normal to the plane containing V and B, that is directed along PO. So when a perpendicular force acts on a moving particle, it follows a circular path. So it means this charged particle, when enters in a uniform magnetic field, which is normal to the plane of the board directed inwards and with velocity v in the plane of the board directed upwards, then it will experience magnetic force in accordance with the Fleming left hand rule, which is directed towards left in the plane of the board. And when a perpendicular force acts upon a charged particle, it follows a circular path. So it will follow a circular path like this. And the necessary centripetal force is provided by the magnetic force, because centripetal force is must for a circular path. So therefore, by Lorentz force equation or magnetic force, F is given by Q V cross B. So V cross B, or F is equal to Q B B sine 90 degree, because angle between V and B in this case is 90 degree. Therefore, we have F is equal to Q B B, equation number 2. So this gives the magnitude of magnetic force experienced by a charged particle entering a perpendicular magnetic field with a speed V. Then, and for circular path, centripetal forces must. So centripetal force is given by F is equal to mv square by r by definition. So this means as this centripetal force is provided by this magnetic force, therefore this equation number 2 must be equal to 3, or mv square by r is equal to qbb, or 1v cancels, so we get r is equal to mv upon bq. It means radius of the circular path followed by the charged particle in a uniform magnetic field is directly proportional to speed of the charged particle, or we can say that this radius is directly proportional to momentum of the charged particle. So more is the momentum, more is the speed, more will be the radius of the circular path covered by the charged particle. Now, time taken to complete one rotation is called time period. So T is given by 2 pi r circumference upon speed, because the circular path speed of the particle remains same, only direction changes. So 2 pi upon b, substitute the value of r, mb by bq, 1b cancels. So we get T is equal to 2 pi m by bq. It means time period is independent of speed of the charged particle. It depends only upon mass of the particle, charge upon particle, and magnitude of magnetic field. Then frequency 1 upon T is given by bq by 2 pi n. So this means frequency is also independent of the speed of the charged particle, and this frequency is known as cyclotron frequency. So this will be the principle of cyclotron basically. Now second case, when charged particle enters at an angle theta less than 9 degree and greater than 0 degree, at some angle theta, suppose this is a magnetic field left to right along x-axis, this is y-axis, z-axis. Now suppose charged particle q enters with velocity v. Now this velocity can be resolved into two triangular components, v cos theta along x-axis and v sin theta along y-axis. It means this charged particle is affected by two components. This V sin theta provides the perpendicular force, rectangular component, perpendicular direction of magnetic field will put the particle in circular path. But this component V cos theta will put the particle into its linear path. So it will have two types of paths. One is linear path along x-axis, that is in the direction of magnetic field, and another is circular path. So due to component V sin theta, it follows circular path, and due to component V sin theta, it follows linear path. So magnetic force in a direction perpendicular direction of magnetic field is given by Q. Instead of V, we have V sin theta into B, QBB sin theta, and it follows circular path. And for component V cos theta, it follows linear path. So as a result, it is following circular path, but it is heading along direction of magnetic field also. So circular path ही follow कर रहे हैं, नानल linear path ही follow कर रहे हैं. So it will path will be like this, and such a path is known as helical path. So it will be a helix when charged particles enter in a magnetic field at an angle theta, which is less than 90 degree and greater than 0 degree. So it means while moving in a circular path, it is moving along the direction of magnetic field also. So the linear path covered by the charged particle, when it completes one full rotation in circular path, is known as pitch of the helix. So pitch of helix is given by velocity along x-axis or along magnetic field direction. So V cos theta into time period, time taken to complete one rotation. So it will be V cos theta into 2 pi m by BQ. So this gives expression for pitch of the helix. So this helix or helical path, you can say, has axis along the direction of magnetic field. And when charged particle is at rest or moving parallel or anti-parallel to the magnetic field, there is no magnetic force. So it will experience magnetic force and follow some path only when it enters magnetic field at some angle greater than 0. So this is all about behavior of a charged particle in a uniform magnetic field. It means charged particle in a uniform magnetic field experiences a circular path, and radius of circular path is directly proportional to speed as well as its momentum. Thank you. All the best. Be happy. Good luck.